Have you ever found yourself staring at your monitor, looking at that little network icon in the corner?
Oh, the one with full bars.
Yeah, exactly. You have full bars. The connection appears absolutely flawless. And yet, when you try to pull a Docker image or even just load a text-heavy web page, the internet is crawling at dial-up speeds.
It is uniquely frustrating.
It really is. Because you know the hardware is capable, you know the network is live, but somewhere in that invisible handshake between your machine and the router, something is fundamentally broken.
Right.
So today we are taking a granular look at that exact scenario. We are jumping into a really fascinating deep dive based on a March 2026 blog post hosted over at kianiming.org.
And the title of that post is very specific.
It is. It's titled Notes on Networking Part 12. Why your MediaTek MT7925 might be dropping to 6-hour GPs.
Which is a title that speaks directly to a very modern pain point for hardware enthusiasts right now.
Definitely. And our mission for this deep dives is to basically follow the digital footprints of a veteran open source developer to solve this Wi-Fi 7 mystery. We are going to learn how to think like a systems troubleshooter and decode that hidden world of hardware and software communication.
To appreciate the methodology here, I think we should establish who we are actually following.
Yeah, let's do that.
The author, Ang, describes himself as an old software plumber.
I love that phrase.
It's great. He's someone who spends a significant amount of his time tinkering with Floss, which is free Libre and open source software.
Yeah.
But what really stands out when you look at his site isn't just the technical depth.
It's the sheer scale of it, right?
Exactly. The persistence of his documentation. His archives go all the way back to 2011.
Wow.
We're talking about 15 years of continuous methodical archiving of his daily technical encounters.
The volume is staggering. Looking at the source here, he published 732 posts in 2024.
And then in 2025.
Another 730 posts. That is literally 2 posts a day, every single day for years.
Which requires an incredible amount of discipline.
And the breadth of his project categories is wild. You have notes on Elixir and Erlang programming.
Very technical.
Right, and notes on Rust, notes on AI. But interspersed with all those deeply technical subjects, you also have notes on gardening, notes on fish keeping, and even beta spawn logs.
You know, that variety actually tells us a lot about his mindset.
How so?
Well, whether he is breeding betta fish or compiling an experimental Linux kernel, his approach is identical. He is someone who meticulously tracks processes, he monitors the inputs and the outputs, and he logs the variables.
Just a highly systematic brain.
Exactly. When a developer with that kind of systematic brain encounters a leak in their digital pipes, they don't just reboot the router and hope for the best.
They trace the protocol stack all the way back to the source?
Yes. They look at the flow rate and the structural integrity of the entire system.
Okay, let's unpack this. Let's get into the specifics of this digital leak. The hardware at the center of this is the MediaTek MT7925 Wi-Fi 7 PCIe card.
Which, on paper, Wi-Fi 7 is designed to be a massive leap forward in throughput and latency.
Massive. But Ang is dealing with what he calls a glaring issue. He pulls up his network diagnostics and he sees this wild, massive asymmetry.
The bit rates.
Right. His TX, his transmit bitrate, is sitting at a beautiful 720.6 megabits per second. But his RX, the receive bitrate, has plummeted to exactly 6.0 megabits per second.
And that kind of massive asymmetry completely breaks the usability of the network.
Because it's so unbalanced.
Exactly. A 720 megabit TX means his machine is pushing data out to the network flawlessly. If you were seeding a massive database, it would fly.
But with an RX of 6 million?
The inbound traffic is completely bottlenecked. I mean, it doesn't matter how fast you can talk if it takes you minutes to hear a single sentence in response.
So Ang notes a crucial clue right away. He checks his diagnostic output and sees that his signal strength is sitting at a very healthy negative 46 dBm.
What's fascinating here is how he uses deductive reasoning with that number.
Walk us through that.
Because the signal is incredibly strong at negative 36 dBm, the culprit absolutely cannot be distance.
Right.
It can't be a weak router. It can't be interference from a wall. So it must be localized interference, a hardware mismatch, or a driver bug.
Because if he has a crystal clear line of sight to the router, what is actually forcing the adapter to drop the RX down to that specific 6.0 number?
And that specific number is actually the key to the whole mystery.
The 6 millips.
Yeah. 6 millips isn't just an arbitrary slow speed. It is the absolute base rate for legacy 802.108 and G protocols.
Wait, so it's a fallback?
Precisely. What Ang is observing here is a hardware survival mechanism.
Okay.
The Wi-Fi adapter is struggling so hard to decode the high-speed data from the router that it is dropping packets left and right. It panics.
So to prevent the link from completely timing out and dropping the connection altogether?
It abandons all the advanced Wi-Fi 7 capabilities. It drops to the slowest possible speed just to keep the physical link alive.
So the card is basically throwing its hands up and saying, I can't handle the gigabit traffic. Let's just pretend it's 2003 again.
That is exactly what it's doing. It enters a fail-safe mode. But the question Aang has to answer is why a cutting-edge Wi-Fi 7 card is failing to decode the inbound traffic in the first place.
Especially with that negative 46 dBm signal.
Right.
So this is where his troubleshooting methodology gets really elegant. Instead of just throwing different driver versions at the wall and hoping one sticks, he isolates the variables.
By changing the bands.
Yes, he forces the network to test exclusively on a single 2.4 gigahertz band. And when he pulls the diagnostic output for that isolated test, he spots a very specific status flag.
The EHT-NSS1 flag.
Exactly. EHT-NSS1. Can you translate that technical jargon for us?
Sure. Those acronyms carry a lot of weight in the networking world. EHT stands for Extreme High Throughput.
Which is kind of the hallmark of Wi-Fi 7, right?
It is the defining physical layer protocol for Wi-Fi 7. But the second half, the NSS1, tells the real story.
What does that mean?
It stands for Number of Spatial Streams 1.
Okay.
Modern Wi-Fi achieves its massive speeds by utilizing multiple spatial streams simultaneously. It bounces different data packets off walls and uses multiple antennas to send and receive mountains of data concurrently.
But the MT7925 is artificially limiting itself here.
Yes.
It has the hardware capability to process multiple spatial streams, but the status shows it is crippled. It's restricted to just a single stream on the receive side.
And Aang deduces from this forced single-stream behavior that he isn't dealing with a hardware defect on the PCI card itself.
Because if the physical silicon were bad...
the transmit side wouldn't be sitting at a flawless 720 millipiece.
Ah, that makes perfect sense.
The culprit has to be the translator between the Linux operating system and the hardware.
Here's where it gets really interesting. Aang zeroes in on the true root cause.
Yeah.
It is a bug in the MT7925E driver within Linux kernel 6.17.
Yes, and he confirms this by digging into the kernel mailing lists and change logs.
But what is the driver actually failing to do? According to his notes, the driver is failing to manage something called MLO.
Multi-link operation.
Right. Can you explain how that failure works mechanically?
So MLO is arguably the crown jewel feature of the Wi-Fi 7 standard. In previous generations of Wi-Fi, your router might support 2.4 gigahertz, 5 gigahertz, and 6 gigahertz bands.
Sure.
But your device had to choose one of them to connect to at any given time. It could switch between them, but it couldn't use them simultaneously.
It's one or the other.
Exactly. MLO changes that completely.
Yeah.
It allows the device to actively transmit and receive data across multiple frequency bands at the exact same time.
So it's aggregating the bands.
Yes, to maximize throughput and drastically reduce latency.
So to use an analogy, it's like trying to juggle two high-speed tasks at the same time. Let's say you're a courier, and you're trying to drive two high-speed sports cars down two different highways simultaneously.
Coordinating the cargo between them perfectly.
Yeah. Right. When it works, you deliver massive amounts of data instantly. But the MT7925E driver in Linux 6.17 is the courier, and it just drops the ball.
It simply cannot handle the complexity of coordinating that data across the different layers. The driver gets overwhelmed by the synchronization requirements of the 2.4 and 5 gigahertz bands.
And it starts dropping frames.
Right. The hardware sees the dropped frames, assumes the link is degrading, and triggers that failsafe we talked about earlier.
It just parks the sports cars and decides to walk the packages to your house at 6 megabits per second.
That is a perfect way to visualize it. Because it fails at MLO, it stops trying to use the Wi-Fi 7 EHT features entirely.
So what does this all mean for anyone actually experiencing this right now? If I have an MT7925 card sitting in my machine and I'm running kernel 6.17, what is the fix?
Aang lays out a very practical mitigation path. Because the issue is rooted in the kernel driver, you have to upgrade your Linux kernel to version 6.18 or 6.19.
Because those versions have the patches.
Exactly. They contain numerous fixes that refine the MLO synchronization and stop the hardware from panicking.
But what if you prefer stability? Some people don't want to manually compile or mainline a new kernel.
For those users, Aang advises waiting for the Ubuntu 26.04 long-term support release, which is coming in April 2026.
Okay.
That release will likely ship with kernel 6.0 or 7.0 out of the box, which will have all those stability fixes baked in natively.
If we connect this to the bigger picture, it really highlights the reality of the open source hardware ecosystem.
It absolutely does. Relying on community patches and checking kernel change logs, just like Ang did for 6.18 and 6.19, is the backbone of how free Libre software improves over time.
Right, because when manufacturers release incredibly complex specs like Wi-Fi 7 MLO, translating that into a stable open source kernel driver takes iteration.
It takes independent developers testing these cards in real-world, messy environments to find the edge cases. They find the bugs, write the patches, and submit them back to the kernel mailing list.
Which reminds us that invisible software plumbers like Ang are constantly doing the dirty work to keep our digital pipes flowing. They do the tedious work so the rest of us don't have to think about spatial streams or multi-link operation failures.
And the value of documenting that work cannot be overstated. By publishing these detailed notes, Ang provides a roadmap for every other developer who encounters this bug.
But what I find really fascinating is how Ang ends his post. He doesn't just give the solution and sign off.
No, he leaves a bit of a cliffhanger.
He does. He tells people who are looking for the best supported Wi-Fi 7 Linux driver to go ask an AI. He gives a specific prompt. Which Wi-Fi 7 Linux kernel driver has the best stability?
And he promises the answer will be, quote, rather surprising.
This raises an important question. Why would an old-school software plumber, someone who clearly values hard empirical diagnostic data, point his readers toward an AI for a hardware recommendation?
It is a brilliant way to end the post. It forces us to think about how we source our technical truths.
What do you think the surprise entails?
Well, considering how AI models aggregate data, it's highly probable that the AI confidently recommends the exact driver Ang is struggling with.
The MT7925E driver.
Yeah. The AI might scrape MediaTek's marketing materials and the initial Linux kernel commit logs that say MT7925 support added and synthesize that into a recommendation for stability.
Because it lacks the temporal awareness to realize that added support does not equal stable support under MLO load.
Exactly. Or perhaps the surprise goes the other way.
How so?
Maybe the AI reveals that none of the bleeding-edge Wi-Fi 7 drivers are truly stable across the Linux ecosystem yet. Maybe it tells you to downgrade to mature Wi-Fi 6 hardware.
What stands out to you about relying on AI for hardware recommendations versus a veteran blogger?
To me, it's the contrast in the troubleshooting methods. Ang is a human being who physically installed the card. He monitored the real-time byte rates. He observed the physical signal strength.
He experienced the failure state firsthand.
Yes. An AI, on the other hand, is just predicting the next most likely word based on a vast, disconnected ocean of text. It has never experienced a dropped packet.
It can read a spec sheet that says extreme high throughput, but it takes the human software plumber to realize the driver is completely overwhelmed and walking the data packets to your house.
It is a great reminder that while AI is an incredible tool, it struggles with the messy, undocumented realities of bleeding-edge hardware.
So let's briefly recap this journey. We started with a frustrating scenario, a 6 Mbps drop on a brand new Wi-Fi 7 card.
And we uncovered a multi-link operation failure in kernel 6.17.
All thanks to a systematic breakdown by an old software plumber. And the reason you should care about this is that troubleshooting isn't just about restarting your router.
It rarely is.
It is about looking at the data, looking at the signal strength and the byte rates to tell a story about where the breakdown is actually happening.
Knowledge is most valuable when it is understood and applied. We really want to encourage you to peek under the hood of your own tech annoyances rather than just accepting them.
Find your own equivalent of the EHT NSS1 flag.
Exactly. Reclaim a little bit of agency over your hardware.
As we wrap up, I want to deliver a final, lingering thought that builds on that AI cliffhanger. Think about Ang's 15-year archive of incredibly niche problem-solving, from Wi-Fi driver bugs to gardening notes.
A massive repository of human experience.
Right. As we move into an era where we rely more and more on AI to answer our tech questions, we have to ask, where does the AI get its answers?
From the training data.
Exactly. It gets it from the meticulous write-ups, forum posts, and bug reports generated by people like Ang. So if the old software plumbers stop writing these highly detailed personal blog posts...
Because they think everyone is just using chatbots now.
Right. If they stop, what happens to the AI's ability to help us troubleshoot the bleeding edge of technology tomorrow?
Without new human documentation, the AI's knowledge base just freezes in time. It's a delicate ecosystem.
It really is. Thank you so much for joining us on this deep dive. Keep tinkering, keep looking under the hood, and we'll catch you next time.